In this video, I'm going to show how to develop an HMS model. HMS is a model that's put out by HEC or the Hydrologic Engineering Center. And I'm going to show how to develop one of these models from scratch. I do use the example that's on the HEC website, and it's a good example. It goes through how to develop a basin model, meteorologic model, control specification file, and then also how to do a simulation and look at the results. Again, it is a simple model that we are developing, but it's a good way, it serves as a very good introductory tutorial on how to use HMS. So the first thing that you want to do is to go up to, well, open HMS obviously, and go to File, New. And the name of the project is called Punxsutawney. And there is a description that goes with it. Is headwaters to the city of Punxsutawney, existing conditions. Our location, you can decide what location. I'm going to put it into a directory called YouTube HMS. Okay. The next thing that we're going to do is to create a basin model. First thing we can do also is to set up our program settings with a few defaults. This is good if you are going to use very or standard concepts for loss, transform, base flow. In this case, we are using initial and constant, the Clark unit hydrograph, and the linear reservoir. Now, even though you can specify these as the default, you can go in and change them later. And you can change them in individual basins also. So here we're going to do a new basin model. And we're going to call it Punxsutawney. And then what we need to do is put in some of the components. So what we do is we put in subbasins, and to do that you just click on this subbasin creation tool, and then you can just place your basin. Now we're going to rename this. We're going to put in 3 subbasins, 2 junctions, and we're also going to put in 1 reach. So this is going to be called Stump Creek. And if you want to move it after you put it in, just select the arrow and you can drag it wherever you want. And we're going to put in one that's called Mahoning Creek Local. Put one over here, it's called EB Mahoning Creek. And then we're also going to put in our junctions. So you go to the junction creation tool. Just leave that as junction 1. Put in another junction, which we'll just leave as junction 2. And then we also want to put in a reach. So here's our reach creation tool, and we can just draw the reach. I messed that one up, so we'll redraw it. We can just leave that as reach 1. So now you can see we have all of these different components. We have subbasins, we have junctions, we have a reach, but none of them are connected. So what you can do is, again, use this selection arrow tool. So I'm going to select Stump Creek. I'm going to hit Edit. And then I want to tell it that the downstream is junction 1. And when I apply that, you can see it connects Stump Creek to junction 1. For EB Mahoning Creek, I want it also to connect to junction 1. For Mahoning Creek Local, I actually want that one to connect to junction 2. And then for the reach, I want the downstream to connect to junction 2. Now, one of the things that you'll notice about the reach is that it's not connected. I do want it to connect to junction 1, but in order to have that happen, I actually need to go to junction 1 and then tell it that its downstream is reach 1. And then once I do that, everything is connected. And then I can actually go in and start specifying the parameters for each of these items. So the first thing I'm going to do is to put in subbasin area. So I can change this because I want to see all of the elements, and you can sort this either hydrologically or alphabetically. So I'm going to put in the values for the basin area. Next up is going to be the groundwater. This one takes a little bit of time, or base flow I should say. So we're going to look at all of them. And I don't go into what these parameters mean. That's will probably come in a later video. Again, this is just to show you how to get HMS up and running. A very simple model. So the layers are going to be 2, and we're going to do discharge per area. And so if it's discharge per area, then it's going to be some kind of flow per area, or CFS per square miles. And we'll populate these values. All right, so it looks like that we have this populated for the base flow. So we can apply that. Next up is going to be the loss parameter. So we need to specify the initial and constant loss. And for all of these, the initial loss is 1 inch and a constant loss is 0.1 inch per hour. All right, so we've specified that. The percent impervious is just going to stay as 0. Now we're going to specify what happens to the excess precipitation, or which transform method is used. So we put in time of concentration values. And we're going to put in our storage coefficient values. And we can apply that. And one thing that we need to do is click on the reach. Got to remember, we've got to put on our reach parameters. Now the reach parameter is going to be relatively straightforward. We are going to use simple lag, and we're going to use a lag time of 300 minutes. Okay. So now we have developed our basin model. So we've put in some subbasins. We have put in some reaches. We've put in some junctions. We've connected everything. So now we're ready to move on to our meteorological model. So the first thing that we want to do is to go to the time series data manager. And the time series that we're going to be using is actually in the example that's given on the website, and they have a file that you can download. This is where we'll put in our precipitation gauge data information. So we have a few gauges. Well, we have 3 gauges. One of them is called DUJP. So we can create that. And then there's 2 more. There's PNXP. So while we're here, we'll just put them all in. There is PNXP. And there's also MFFP. Now for each one of these, we're going to need to put in some information. So there's our 3 precipitation gauges that we just created. Now the data source is going to be a single record DSS. I'm going to navigate over to where I put that file that I downloaded. So it's this observe.dss. I select that, but then I also want to make sure that I'm telling it what path to go to. So I go to the DUJP, tell it to set the path name. Then I also want to make sure that I'm putting in the right start date. I need to tell it what data am I using. So here I go change this to 28 April 1996 at 0100, 04 May 1996, and that stays at 0-100 hours. Save that. Okay. So now I'm going to do the same thing for this MFFP, single record. I'm going to make sure that I'm giving it the correct DSS file and also the path. So here we have the MFFP. Now I need to give it the correct time. So that's 28 April 1996 at 0100 to 04 May 1996. And finally, there's the PNXP, single record DSS file. Make sure I'm telling it the correct DSS file and the correct DSS path. Now on this one, I did notice in this file there was a flow and a precip. You want to make sure you select the precip, and that's in part C. Then we'll put the correct dates in. And also the correct time. This is 04 May 1996. Okay, I'll make sure that all of these look correct. Okay. So I think that we're okay with this. We can save that. Now we have our time series data in. And now what we want to do is a new meteorological model. I want to call that new. And we're going to call this May 1996. And we'll put a description there, precipitation for the storm of May 1st, 1996. And we'll create that. Now for this, we want to make sure that the precipitation is a specified hyetograph, and also the evapotranspiration and snowmelt is set to none. We don't have any information for that, plus we're making a very simple model. And we do want to make sure that we are including our subbasin, so we hit yes. And for the specified hyetographs, we'll have one gauge, or the rainfall at one gauge, related to the individual basin. So for E.B. Mahoning Creek, that's MFFP. For Stump Creek, that is DUJP. And then for Mahoning Creek Local, it is PNXP. So your meteorological model is now created, and you want to create a new control specifications file. And we'll call this May 1996. And we can give it a description of storm of May 1st, 1996. And then we can create that. And we need to put in some data for this. So again, the same storm date, 28 April 1996, 0100. And our end date is going to be 04 May 1996 at 0100. And we select a time interval of 15 minutes. Now in the tutorial it does say, well, what if my data is in hourly? And the answer to that is that it will equally distribute the hourly data over the 15 minutes. So if you have 1 inch of rain in that hour, it'll give it a 1/4 inch for every 15 minutes. So now that you're done with that, you can go in and create a compute. We want to do a simulation run. And we can call this May 1996. And when you're developing a compute, it's going to need to know, well, which models am I using? So it's asking you here, which basin model. We only have one basin model, so we're going to use that Punxsutawney. It also wants to know the meteorologic model that's used. And it's also going to want to know the control specifications file. So here we can see that it did indeed create the May 1996 simulation. So assuming that we did this correctly, we're going to compute it, see if it runs. It does run, so we're successful with that. Now, while we're on the simulation, if you make sure that this arrow is clicked, you can now go look at results. And we'll go look at some of the graphical results. You can see that you're viewing results from May 1996. You can go in and look at the graph, and you can see that you have the red, which is the precipitation loss. And then this blue solid line, or purple maybe it is, that is the total precipitation. So you can see whenever you have precipitation that exceeds the loss amount, then you will get some runoff. Here you can also see in the lower chart that you get This dashed line is going to be your base flow, and then the solid blue line is going to be your outflow. So then you get to see what component of the total outflow is made up from base flow in this particular chart. And that was looking at one sub-basin. You can also do the same thing for junctions. And here you can see you get the results for each one of the sub-basins. So you get results for E.B. Mahoning and Stump Creek, and then you get the total of those two as the total junction, or the total flow at that junction. And finally, you can also go look at reach results. And if you remember this reach, it had no attenuation. It was straight lag, and I think it was 300 minutes that we put in. And here you can see that this is the inflow, and then that's the outflow. So there's really no change in the hydrograph other than it just gets shifted by 300 minutes. So hopefully this was helpful for you if you're looking to learn how to use HMS. This is a good tutorial to go through. If you want to know when more videos come out, either on HMS, DSS, hec-ressim, or I do some Python videos also, feel free to subscribe to the channel, and thanks for watching this video.